when looking into the applications, the main application is to generate a steam in the steam turbine, steam power plants. So with the fluidized bed combustion technology, and so as I said, you can use any kind of fuel, especially the solid fuels, to combust at the controlled combustion temperature, and there where you have very good emission performances. And if you are working with a fuel like a coal which carries sulfur in it, so you have sulfur dioxides and sulfur trioxides in your from your combustion process, and that emits into atmosphere. But when you are using a fluidized bed combustion technology, so you can put additives into the fluidized bed reactor, where this the sulfur in the fuel can be captured into the bed material, and you can refresh bed later on. So then you can you can eliminate emitting sulfur exhaust as well as sulfur exhaust as well. So that is also one very good advantage of fluidized bed combustion technology. And you can also see today in the today's power production, mostly the power plants are based in natural gas burn combustion techniques with the combined cycle applications. But also don't forget that the natural gas reserves are also limited, and you have very much more coal in the world. So the coal will be the main contributor to the power production in the future. So then you need advanced combustion techniques to utilize coal also together with other kinds of the solid fuels in the better way. So the fluidized bed combustion technology will be a very good technique to have in the future as well, and not only in the future. So I can give you one example which is very close to our institute in Stockholm city, and where the emission concerns are really high in this world. So we are having a power plant which is burning coal, situated in the middle of the city and having very good emission performances. Otherwise we are not allowed to operate such plants in the middle of the city. So here I can show the sketch of that power plant. This is also a kind of combustion combined cycle power technology, but this is not the one you are very familiar with, natural gas burn combined cycles, where you have topping gas turbine cycle and bottoming steam cycle. This is a different kind of combined cycle which is in operation for 20-30 years. The difference is which has a lower efficiency than natural gas based combined cycles, but this burns coal which is not clean fuel as natural gas in a better way. And in this process we have the fluidized bed combustor under pressurized condition, and we have the gas turbine compressor compressed air and sent into the fluidized bed reactor, and the exhaust coming from the fluidized bed reactor goes through the gas turbine to produce heat. Here gas turbine produce like 74 megawatt electricity, and also the pipes immersed into the fluidized bed reactor from the steam cycle takes the heat to the cooling flows to generate steam and run the steam turbine, and the electrical production from the steam turbine is like 260 megawatt electricity. And you will see that in this process the gas turbine produces only 1/5 of the power of the total plant, but in the natural gas based combined cycles, gas turbine produces like 2/3 of the power that you are taking from the plant. But still this has very good efficiency, this has a better efficiency compared to the stand-alone steam production steam power plant. And the important point here is it has a common combustor for both gas turbine as well as for the steam turbine, and the common fluidized bed combustor is sharing by both cycles, and the combination of the cycle is by the common combustor.